Hi geometry students, you're watching the guided notes for lesson 5. In your workbook you should be on page 141. We're talking about the volume of cones. A cone is really similar to a pyramid. So you should have already watched the notes for pyramids. It has a base that could be really any shape at all, and then we have these lateral faces that come up to meet the apex. The only difference is all cones have a circular base. If you have what's called an oblique cone, that's just not a right cone. So this on example 1 is not oblique because I have a right angle where the apex would intersect the base. So this one is a right cone, not an oblique cone. But if you look at number 2, both of these are oblique cones because the apex is not perpendicularly aligned with the center of the base. So those ones are just a little more complicated when we go to find their area. You'll see in a second when we get there. But we're just going to talk about the formula for the volume of a cone. Just like a pyramid, it's got this 1/3 in the formula. It's still 1/3 area of the base times the height. But like I just said, if the base is a circle, then the area of the base will always be pi r squared. So the formula for the volume of a cone is 1/3 pi r squared times the height. We're going to have to deal with in terms of pi and rounding, just like what we had to with the cylinder as well. So for number 1, we have this right cone. The apex is perpendicular with the center of the base. So I'm going to be using my formula, 1/3 pi r squared times h. R is always the radius of our circular base. And I can see that the distance from the center to the edge of the circle is already labeled as 4 centimeters. So we already had the radius. And we're going to multiply by that height. The height is the perpendicular distance from apex to base. This one happens to be directly over the center, which is why it's not oblique. Now, this will depend, how you put this in your calculator depends on your particular calculator. If you have the type that will do in terms of pi and you could just push that button above enter to get the rounded version, awesome, type in everything you see. If you have a graphing calculator or one of the, I think pretty much any other, some of the Casios should be fine, but most other calculators, the moment you type the pi button, which you absolutely should be using, the moment you use that button, you're going to get a decimal, which means you're about to get the rounded answer. So for example, I have a graphing calculator personally that I use. Looks like this. So if I type in 1/3 times pi times r squared times the height, I'm going to get a decimal, which does tell me to the nearest whole number, the second part, it's about 50 for that answer. But if I want the in terms of pi, I need to not type this pi in. So 1/3 times r squared times the height, and then just by hand write pi after that. So I mean, here, if I just take 1/3 times 4 squared times 3, I get 16, and it would need to be multiplied by pi. The volume in terms of pi is 16 pi. To the nearest whole number, this is when I let my calculator know pi was in there, and it was 50.2 blah 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 blah. Since I want a whole number, this 2 doesn't make it round up, it makes it stay the same. This would be about 50. This is still volume. You can see up here I have centimeters being squared. If you think back to your exponent rules, centimeters squared times the centimeters would be centimeters cubed. That's part of the reason volume always have units in cubic units, and because they're 3-dimensional shapes. That's like the basic type of cone problem. That's like best case scenario, what you could be asked to work on. Excuse me. Number 2 is like worst case scenario. Because I do have a cone, I am still going to use 1/3 pi r squared h. When I look at my picture, the radius is the distance from the center to the edge. That's labeled for us. It's 7. However, h is not labeled. We're going to have to find it, And I need to pay attention to the shape in this picture. So let me change my color so I can draw special attention to it. This height that we're going to be finding is part of a triangle. Specifically, because there's a right angle here, it is part of a right triangle with a hypotenuse of 19 and an acute angle of 56 degrees. Feels like a lifetime ago, but we spent a whole unit talking about right triangles and how to find missing sides. Specifically, this acute angle has that height on the opposite side of the triangle. It's not next to the 56, it's opposite the 56. And the adjacent leg, this one down here that 7's part of, I don't know the whole length. I know that 7 stops here, but since I don't know this part, I don't know the whole adjacent leg. So because I don't know it, I'm going to ignore it. I'm not going to think about the adjacent leg, and I'm just going to think SOHCAHTOA. If I have an O and an H, I'm working with the sine ratio, and we always say sine of our angle is equal to the opposite leg over the hypotenuse. Excuse me. Then I'm just trying to solve for H. And since H is over in the fraction, I don't need to do inverse. I just need to get it by itself. A lot of times we'll make a proportion and cross multiply. H times 1 is H. So all we'll need to do is 19 times the sine of 56. That is what's going in here. So what I'm going to do, actually, because I don't want to round before I'm done with the problem, this entire expression is going in again for H. So 19 times the sine of 56. If you went ahead and rounded, you might be right in the end, but your answer is probably going to be a little bit off, and I don't want that. This is math. We want precision. So now the directions don't ask in terms of pi, so I don't need to care about this, whether I put pi in or not. I'm literally going to type in everything I see here into my calculator. So give me a second. 1/3 times pi times 7 squared times 19 times the sine of 56. My calculator just spit out 808.26 blah 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 blah. It says nearest whole number. 8 is in the whole number spot, and this 2 is less than 5, so it's going to round to about 808, and again these labels are in cubic inches. So it's a pain when you have an oblique shape because there's just a lot of stuff you don't know. Speaking of things that are a pain, part B. Still a cone, so I'm going to use my cone formula. But if you look at this one, we don't know the radius. That's annoying. We don't know the height. Also annoying. I'm really sorry. But just like the other one, I do have a right triangle. And right triangles give us a lot of power. There's a lot of things we can do when we have a right triangle. So I'm going to focus on the right triangle. In the right triangle, the only things that we do know are the 22, which I'm going to label as my hypotenuse, and the 40-degree angle. I'm going to have to find both H and R. I'm going to start with H. Since my acute angle is up here, H is not across from it. H is right next to this angle. It's right here. So because it's right next to it, this is my adjacent leg. SOHCAHTOA tells us that we're going to use a cosine ratio. So cosine of my angle is equal to the adjacent leg over the hypotenuse. And then I'm going to cross multiply because it's the same type of setup as our last one. You're not finding an angle. You will not do inverse. The height will be 22 times the cosine of 40 degrees. That's again going in for H. The radius, however, is going to be a little more annoying because this side of the right triangle, I'm going to call it X temporarily, is the opposite leg in that right triangle. But R is not the same thing as X. Since X goes all the way across this circle, X is the diameter. We're going to have to take half of that after we find it. Like I said, it's a pain. But since I know the hypotenuse, Since I'm finding the opposite leg, I'm going to use a sine ratio. I'm just going to ignore the fact that we know something for the adjacent leg because I don't want to round. Sine of my angle is equal to the opposite leg, which I've called x for now, over the hypotenuse. So when I cross multiply, x times 1 will be equal to 22 times the sine of 40. And again, this is our diameter. I don't want the diameter. So if I want only the radius of it, if I don't want this whole thing, I'm going to have to cut it in half. So if you think of dividing this by 2, what I want to point out, you can just quickly divide that by 2. The radius I can write is 11 times the sine of 40 degrees. So we now know what r is in this equation. We already had something for h. It's going to be a pain, but we have enough to plug this in our calculator. So the volume will be found by 1/3 pi. The radius, I'm going to go ahead and color code this. The radius was 11 times the sine of 40. We're going to square that, so I'm going to have to use parentheses. Then I'm going to multiply by my height. The height is 22 times the cosine of 40. Really, 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 really long, difficult problem. But we can do this. So, I think I'm going to try and show you on our calculator, on the actual calculator. So again, I have a graphing calculator, but it was, probably should have took note what this was. 1/3 pi, so 1/3 times pi. And then in parentheses, we need to do 11 times the sine of 40 degrees. So you'll notice it opened parentheses when it said sine, so I closed it when I said 40. But this whole radius of 11 sine 40 needs to be in parentheses so we can square it. And we're going to multiply that by the height, which I have here. The height was 22 cosine of 40. Not that. Sorry. So 22 cosine 40. 882.3. Oops. 882.3. Since it said whole number, this 3, again, we've had a lot of rounding down on these examples. And since everything in this problem was labeled in, well, the only thing in this problem was labeled in feet, our volume will be calculated in cubic feet. You should not expect a ton of problems like that, but it is a nice throwback to, hey, we know right triangle stuff. But like I said earlier, this is like best case scenario. This is the easiest type of problem we could give you. 3 is similar to it, but it's just like an extension of it. We have a composite figure, which just means we took 2 shapes and we glued them together. So the 2 shapes in here is the cone on top and the cylinder on bottom. So the volume of a cone, we just said, is 1/3 pi r squared h. And the other lesson talked about how, I think it was lesson 3, said that for a cylinder, it's just the area of the base times the height. It's just the pi r squared times the height. So in the cone, I need to look for the radius. Well, if we pay attention, this is also, this circle is the base of the cone. It's also the base, one of the bases of the cylinder. And in the cylinder, we know the radius. The cylinder has a diameter of 12. Therefore, the cylinder has a radius of 6 meters. Therefore, the cone has a radius of 6 meters. We need to multiply by the height that's given to us, so 8 meters. And I'm going to add on, because I'm just gluing together the cylinder. We just said that it had 6 meter radius, and it also has a height of 8 meters. Directions says in terms of pi. I already told you my calculator cannot handle pi unless I would like something rounded. So I'm typing in everything I see except the pi's. So it went ahead and added it for me, or I told it to add for me, and it summed total 384. This plus this without the pi, so I need to write the pi in myself. And since this would have been in meter cubed, and this is also in meters cubed, when I add, I still have meters cubed. And then I'm going to go to my calculator, tell it to multiply by pi. Again, nearest whole number. Again, we'll round down because this 3 makes the 6 stay the same. So it's about 1,206 cubic meters. Another way that we can kind of extend this is to kind of try and visualize three-dimensionally what's happening here. And this is kind of hard for some students to see. So give yourself a little grace here. Sorry. We have a triangle. It reaches all the way up to 5, extends all the way over to 2, but fills in all the other space as well. And it's going to be rotated. Specifically, it's being rotated. What am I doing? It's being rotated around the y-axis. So if I just don't rotate it for a second, if I just reflect, if we go back to first semester when we did reflections, the y-axis is the line I'm reflecting over. This dot here is 2 units away from the y-axis. So when I flip it over, it will go 1, 2 units away also. Whereas this dot up top is on the y-axis, which means when I would go to flip it, it stays the same. So if this was just reflection over the y-axis, it would look like this. So just flipped over. But I'm supposed to be revolving it, which implies I'm spinning it. So you can kind of picture this dot. To get here, I'm going to pick it up. So picture it coming out of the screen towards you before going behind the paper behind it. That's the same thing for like this part of the hypotenuse shape. It's going around and around and around. What you would end up having, since I'm revolving it, since it's coming out of my paper and behind my paper, it's a three-dimensional shape. Specifically, this is a cone. So we can find its volume because that's what this lesson's all about. And since I kind of have it sketched, we can see the radius. The center is that y-axis, the thing I'm rotating about. So the edge of the circle would be here. I probably should have changed color so you can see what I'm talking about. But it's that y-axis to the edge of the base circle, which means it's 2 units. The height is the distance from the apex, the pointy part, to the base. Since we said this point was 5 above the x-axis, that means this height has a length of 5 units. It says in terms of pi, so I'm going to put this in my calculator. I'm going to get a fraction, and that's okay. Specifically, my calculator spits out 20 over 3. Some of your calculators, when you put that in, will spit out 6.66666666666, which we don't want. You also don't want 6 2/3, because like I said, I still have to put pi on this, and we don't use mixed numbers with pi's, so don't. You need to know how your calculator works to get 20 over 3, because that is my volume, 20 over 3 with a pi. You will sometimes see that pi put up in the numerator, so it doesn't look like it's with the 3. So this is just as correct as 20 pi over 3. Personally, I tend to write this one, but as long as you do this one without the pi looking like it's with the 3, because it's not, then it's also equal. It's equivalent. It's correct. Cubic units. It changes if I take that exact same picture and revolve it differently. Let's change colors. Let's do purple. If I flip this over the x-axis, again, we will eventually revolve, but for now I just want to flip. This point is on the y-axis, but it's not on the x. It's 1, 2, 3, 4, 5 units from x. So I would need to reflect it 5 units away from x. So it's now here. But again, if you start on the x-axis, you'll stay on the x-axis. That reflected triangle would look like this. But again, it's not a reflection, it's a revolution. So we're spinning it. This dot will come in front of the paper and spin behind the paper. All the dots will go in front and behind. So you still get a cone. It just looks different than the one we were just looking at. This one looks like the traditional, it's standing up type of cone. This one looks like a weird flat type of cone that was flipped sideways. So the circle is kind of standing up on edge, and then it's pointing out to the side. It is still a cone. We'll still use 1/3 pi r squared h. So I'll still need the radius. Remember, the radius is the distance from the center of the circular base to the edge of the circular base. Sorry, I should have brought some water with me. The center is here at the x-axis. So this distance is what we're interested in, which we already knew was 5 units. The height is the distance from the base perpendicular to the apex, which we already counted out earlier was 2 units. Put that in your calculator. Some of your calculators will immediately spit out 50/3. Some of your calculators will spit out 16.6666666666666666666. It'll eventually round to a 7. We don't use decimals with pi, so don't tell us this one. Also, don't tell us the mixed number. We don't use mixed numbers with pi. This is the one that would be our volume. So 50/3 with a pi after it, which is the same thing as 50 pi over 3. So your volume changes depending on the thing you rotate about. So be careful with that. A and B are not the same answer. A couple more. A sculptor wants to remove stone from a cylindrical block. So we have a cylinder. It is 3 feet high. So this cylinder starts out 3 feet high. And turn it into a cone. So the goal is to get a cone. The diameter of the base of the cone and the cylinder, because they're the same, is 2 feet. So this entire length is 2 feet. What is the remaining volume of the cylinder? So we are taking this cone out. If you're taking something away, you are subtracting it. So we're starting with the cylinder, and we're taking out a cone. So if I'm interested in the volume, I'm going to start with the whole cylinder, and I'm going to remove the cone. So in this in the cylinder, I need the radius first. The radius is the distance from center to edge. That's not currently labeled because I want to go center to edge, and 2 feet is the entire length. So I just want half of that. My radius is 1 foot. And then the height, we already were told, was 3 feet. So this would just be times 3 feet. So if you wanted to, you could go ahead and find that this whole cylinder is 3 pi cubic feet in volume. I can also do the cone, though. Pretty easy because we just did the work. We just said that this radius is a foot, so it's still a foot. And this height is still 3 feet. Here comes my kid. Sorry for the interruption in advance. What's up, buddy? I'm trying to teach some of my students. Don't step on that, please. What do you need? Stop stepping on that. Get out. What?
Why'd you walk in?
Because I was expecting you to not be in here. I know you're in here now.
Mommy.
No, I'm not holding you.
I'm
Ow, careful. Let me finish it, and I will come over there, come to you, and then you could sit on my lap. Let me finish, okay?
I won't go in my room. I want to lay down.
Okay.
On my bed.
Give me a moment. You go in there and get started, and I'll come in when I'm done. Okay, sorry, guys. So anyway, I could do them in separate steps and then go ahead and subtract. If I have 3 pi's and I take away 1 pi, I have 2 pi's left. If I had been really careful, I could have put this whole thing in my calculator. As I said before, depending on your calculator, depends on whether you put the pi's in or not, and it's going to spit out either 2 or 2 pi. Neither of which I want, because it says nearest hundredth. So when I put that in my calculator, it spits out 6 point. The 2 is in the tenths place, the 8th is in the hundredths place. This 3, after the 8, makes it stay the same. So I'd have 6.28 cubic feet remaining after the cone has been removed. Really annoying, and I'm sorry. Number 6 is a backwards problem. The volume is. Normally, every problem up to now, we are finding the volume. If we're talking the volume of a cone, I still have to care about this formula. But now, if the volume is already found, we've already found the volume. So I'm going to put 54 pi where it says volume. And then the height is 2 feet. We're eventually going to find the circumference, but you'll notice circumference is nowhere in our initial formula. So I'm just going to find what I can, and what I can find is the radius. So I'm going to solve this for r. There's lots of ways you can start out. Personally, I'm going to get rid of the pi. I don't like having equations with pi on it. Since we have multiplication, I'm going to divide by pi. Pi is on both sides. I can just ignore it. So 54 is 1/3. That was supposed to be a 3. 1/3 r squared times 2 is what's left. I'm going to divide by 2 because I can. If you would have caught me in a different mood, maybe I would have gotten rid of the fraction first. It's definitely a totally fine option. You have 2 options. Depending on how good your calculator skills are, you can absolutely divide by 1/3. But if you are 1/3 of my age, you can find my age by multiplying by 3. So this divide by 1/3 step is the exact same thing as multiplying both sides by 3. So if you did 27 divided by 1/3, you're going to get 81, just like 3 times 27. Which is really nice because since I have something squared, to undo a squared, we solve by square roots. Our radius is 9. However, I didn't ask for the radius, ask for circumference. It's been a long while since we did this formula, or maybe it was in the cylinder unit. I don't really know. Whatever. 2 pi r is our circumference formula. And since we now know r, we can solve this. 2 times pi times 9. And there aren't rounding directions, so I'll just assume I wasn't asked to round. So 2 times 9 is 18. I'll put the pi on the end. 18 pi feet would be our circumference. I'm not sure I'm going to do both of these just because they're really similar to ones that are above, and this video is already long enough. I'm going to talk about them though. Number 7a, you are revolving this about the y-axis, which is this one. I always recommend you start by doing a reflection. So if you're on the y-axis, you stay on the y-axis. But if you're, say, 1 unit away from the y-axis, go 1 unit on the other side. 1 unit away, 1 unit on the other side. So if you just do a reflection, you would have that exact same, I don't even know how to describe that shape, except for now it ends up completing like a whole house. But you're going to be revolving it. So if you picture that thing coming in front of my screen and then going behind it, in front, behind, in front, behind, in front, behind, you kind of have a combination of shapes. This is a composite figure. You would have a cone on top. You would also have a cylinder on bottom. So let's pretend you actually wanted to finish this problem. The cone has a radius of 1 because this y-axis is 1 unit away from the base. Sorry, not from the base, from the edge of the base. The cone has a height of 2 units because that center is 2 units from the apex. The bottom shape is a cylinder. The radius is also 1 because it shares this base with the cone. Or you can look at this one or this one. Either way, the radius is 1. The height is 3 though, because I would be going from this circular base to this circular base where the cylinder ends. The distance there is from -3 to the x-axis. That's a distance of 3. So I lied. I am going to do this problem. So my cone, 1/3 pi r squared h, plus my cylinder, which is just regular pi r squared h. I'm just going to plug in those numbers. 1/3 pi times 1 squared times 2 plus pi times 1 squared times 3. Let me look at rounding directions. It says in terms of pi. So this first one would just get me 2/3 pi. The second one gets me 3 pi. I don't want 3 2/3 pi. So if your calculator just adds those like this, say nope, not acceptable. If you put 3 2/3 in your calculator and then use your calculator's programming to get you the fraction, the improper fraction that is, you can find that it would be 11/3 pi. So again, I don't necessarily intend to completely do all of part B, but again, I didn't mean to do all part A either. This one is also a revolution, but now you're revolving around x equals 2. This is an equation of a line. That line cannot be put in slope-intercept form, so it doesn't have a number for a slope, meaning it has an undefined slope. We're looking at a vertical line. All the points with an x value of 2 are on this vertical line. So starting with your reflection, this is the only dot on that line. This point is 2 away from the line, so it goes over to 4. This dot, which is 5 up, is also 2 away from the line. So if I just do our reflection, you get this thing. But I'm revolving it. So this dot comes in front of the screen and then goes behind the screen. This dot comes in front of the screen and goes behind the screen. And if that's all it is, you'd have a cylinder. I have 2 exactly the same circles. But that's not all I have, because if I look at like this spot, it's not a nice point, but if I looked at this spot on that hypotenuse, it would only come to here, meaning it's not all a cylinder. In the middle of this cylinder is a cone, specifically a cone that would not be shaded. That cone has been carved out, which means it's going to look very, very similar to this. So I'm not going to do all of this one, I promise this time. I'm just going to outline what the radius and the height would be, and then if you are really ambitious / bored, you could plug it in here and figure out what your volume would be. So in this shape, let's talk about the cylinder first. In the cylinder, we would have a radius. So again, the cylinder has the big circular bases, so one of these circles or the bottom circle. Either way, the radius is 2 because the distance from this line to the edge is 2 units. The height would be 5 because this top circle to this bottom circular base is a length of 5. Nice thing, the cone has the exact same radius and height because it's been carved out of it. So this cone also has a radius of 2. This cone also has a height of 5. So really you're just typing it into this. You're going to get, what is it, 2/3. Let me actually find it for you. I keep lying to you saying I'm not going to do it, and then here I go doing it. If you're wanting to check your answer because you're really ambitious / bored, you should get 40 pi over 3 cubic units. And if you try doing that and it doesn't turn out to be that, there's a chance I'm just wrong because I didn't show any work, and that's always a bad plan. But it's also a good chance that you might have typed it in wrong. So if you're getting the wrong thing and you cannot find your mistake, that is a great time to email your teacher and check to make sure that your teacher's staying inside and washing their hands and staying healthy, because that's the same thing you should be doing. Do some math, wash your hands, go to bed at a